Okay, welcome back everyone. Today we'll be talking about the interconnections between the reduced order observer and the parity space approach. To recap, we have the dynamics for the reduced order observer as zk plus 1 times g times z times k times h of u times l of y, and the reduced order and the residual dynamics are as follows. Negative w times z minus q times the input plus v times the output, where z is a transformation matrix times the original states to reduce the number of states that we want to actually observe. Whereas the parity space approach is as follows. We have the residual signal as the parity vector times the output of the system minus HOS times the input, whereas this condition has to be satisfied, whereas the parity vector times HOS equals to 0. The goal of our video today is to obtain the G matrix, this G matrix, the T matrix, the L, W, and V matrices if we have the parity vector and the HOS vector from the parity space approach. So, meaning if we solve the parity space approach, we can go to the reduced order observer very simple. And this has been solved through this paper by Ding et al. The name of the paper is An Approach to Analysis and Design of Observers and Parity Relation Based FDI Systems. And here's the paper. As you can see, this here he defines the residual as we defined earlier, as the parity vector times the output minus HOS times U of S, and the dynamics as VS times the disturbance plus HFS times the potential fault. And here he has introduced the dynamics of the reduced order observer as we haven't identified before. If we go down, we will find the relationship between the parity space approach and the reduced order observer through the interconnections subsection. Here in theorem 1 we can find the G matrix as a combination of two matrices, G note and G, whereas G note is just a subdiagonal matrix and G is a vector goes from G1 to GS, and G1 GS is a vector that should be chosen by you just to make the matrix G stable. We can find the T matrix as you can see, VS the vector here and the transpose as shown times HOS, and the L matrix as the parity vector minus G, this one, times the parity vector as well, and the W matrix should be just a vector transposed and the last element is 1, and the V matrix just VS. And that's it for today. It was a short video. I hope you found it useful. If you like the video, please like and subscribe. See you next video.